Okay, so today we want to just review solving trigonometric equations. We have a couple here that you're going to have to factor, do some different things. One thing to always be aware of is what your kind of range or the interval that you want your answers in. So here we want x's to go from 0 to 2 pi, which is kind of a typical one. Sometimes they're bigger, sometimes they're smaller, sometimes we can solve for all x's. Okay, so for number 1 here, we have sine squared x plus sine x minus 2 equals 0. Well, this is in the form of a quadratic, right? If this were x squared plus x minus 2, we would be able to factor it, correct? So we can still factor it. So we're going to get that the sine of x times the sine of x, we still have equals 0. So let's see, I need the two numbers that multiply to be negative 2 and add to be 1. So that'd be plus 2 and negative 1. Now, if you're really having trouble factoring that and that doesn't seem okay, you might rewrite it and just use like a simple substitution. You know, maybe think of it as u squared plus u minus 2 equals 0. And then factor it and then put the signs back in for the u. That's, or whatever variable you want to substitute. I would not replace it with x's though, because that tends to be confusing. All right, so now at this point I have a factor times a factor equals 0. And again, there's no point in doing that if I didn't actually have it equal to 0, that 0 product property. So then we get the sine of x plus 2 equals 0, or the sine of x minus 1 equals 0. To solve this, we get the sine of x equals negative 2. Well, sine has to be between negative 1 and 1, right? If you think back to the definition of sine on the unit circle. So this provides no solution. Right? That doesn't give us any part of the solution. Just kind of gibberish, right? There's no x you can put in there to make that true. The other one here, we get the sine of x equals 1. So we want to think about our unit circle in that first rotation. Where's the sine going to be equal to 1? It's a pi over 2, right? So we get x equals pi over 2. Would be our answer there. Now, just to compare, before we move on here, this was the answer because it told us that 0 is less than or equal to x is less than 2 pi. Right? We didn't want all solutions there. But what about, so what if solving for all x, right? So then you would get it pi over 2, but then you could go another rotation, you'd be back at what, 5 pi over 2? Then you could go another rotation, you'd be back at 9. They're just going to keep coming, correct? So in that case, you'd say something like x equals pi over 2 plus 2 pi k. This is like we're adding multiples of 2 pi on, where k is contained in the set of integers. We talked about that notation a little bit earlier in the year, right? So that's a way you could write it for all solutions. This one didn't ask us for all solutions, so it just gave us that one. But I just wanted to point that out, because sometimes it's good to know all solutions. Sometimes you just want to know a couple solutions. If you were having trouble with this at home, working on it, it might be interesting to even graph this function on your calculator and just see where it hits the x-axis, right? Find the intercepts. Now, it's not going to say pi over 2. It's going to say like 1.57, something like that. We good there? Okay. So this next one, if you want to, take a minute and go ahead and try to factor that, see if you can set it up. Let's see how we do. Okay, so looking at this one, we're going to need to factor it again, and you can tell that because it has a cosine squared and it has a cosine. It's equal to 0. Looks like it's factoring. A lot of us are going to be fine. A lot of people are fine factoring this. You might know that there's going to have to be a 2 cosine x to start one of them, a cosine x to start the other one, and then here's a 1 and a negative 1. Some combination will get us there. If you can do that, that's great. But if say you look at it and this isn't working and you don't feel good about it, what I would recommend you do is something like this. I would just off to the side, let's let u equal the cosine of x, right? We do there's whole things we'll do in calculus called u substitution. U is a pretty common variable. So we'll get 2u squared minus u minus 1. Right, now if I'm going to factor this, I can just split the middle. I want to find two numbers that multiply to be -2, that add to be -1. That would be -2 and 1. So 2u squared minus 2u plus u minus 1. Right, and then we get 2u, u minus 1, plus 1, u minus 1. So 2u plus 1, u minus 1. And again, to undo it, we just replace all the u's with cosine x. So you get 2 cosine x plus 1, and then cosine x minus 1. So that's one way to factor it. If you're just not at all having luck with leaving the functions in there, that would be a great way to do that. So what did we say? 2x plus 1, or sorry, 2 cosine x plus 1, and then cosine x minus 1. Now at this point we have two factors multiplied together that equal 0. So our zero product property tells us that either 2 cosine x plus 1 equals 0 or cosine x minus 1 equals 0. We'll solve both of these for cosine. So we'll get the cosine of -1/2, or we get the cosine of x equals 1. Now I kind of go visual here with my whole unit circle thing. Well, cosine is 1. I know that one, right? That's down here, right? So that's there. So that means x is going to be equal to 0. Notice the domain was less than 2 pi, so you wouldn't include 2 pi as your answer. If there was an equal there, you would include 2 pi as your answer. Just kind of a subtle difference. And then -1/2. Well, for starters, kind of some thinking here is I know that the cosine of pi over 3 is +1/2, correct? That's just from my first quadrant. Now, I know all students take calculus. So I know that versions of this pi over 3 that exist in the second and third quadrant are going to be my answer. Okay, so that's over here where the numerator is 1 less, so that's 2 pi over 3. And then over here where it's 4 pi over 3. So then our answers here would be x equals 2 pi over 3 and 4 pi over 3 and 0. Okay, again, might be a good exercise to type this as a graph and check it to make sure that actually is what happens. It's kind of a weird one. They're all like 120 degrees off. You can actually write it kind of a neat way, but we don't need to do that. Okay, so here are a few more here. We have the cosine of 1/3 x equals 0. Now you do notice here the interval for our answers is bigger, right? It goes from 0 to 6 pi. And that's going to be because of that 1/3 in there. We'll see why that happens. Then here we have 2 cosine squared x minus 1 equals 0. We'll take a look at that one also. But for this one here, if you ever have anything weird going on inside the cosine, we save that completely until the end. So the first thing we're trying to figure out is when is the cosine equal to 0. Right? So cosine equal to 0, well that would be up here at pi over 2 and down here at, it's a 2, pi over 2 and 3 pi over 2. Right? That would be there. So that means that 1/3 x either equals pi over 2 or 1/3 x equals 3 pi over 2. Right? Again, you're just, whatever the argument is inside the trig function is what's equal to pi over 2 and 3 pi over 2. So at this point, if I want to solve for x, I just multiply both sides by 3, correct? So here we get x equals 3 pi over 2 or x equals 9 pi over 2. So we see we do have two solutions, and we see why it made the interval bigger. Right? Now, if we didn't make the interval bigger, if it still just went from 0 to 2 pi, this would still be the solution, right? That would be the only solution because this would have appeared out of the interval. Okay. Now, I think what's more important to look at than maybe this question, so I wanted to throw one in here, is, let's say the sine of 3x equals, that doesn't matter, 1/2. I say we have to solve this. 0 is less than or equal to x is less than or equal to 2 pi. So it's really the same idea. The first thing to do is figure out when is the sine going to be equal to 1/2. Right? Okay, now this, again, this is a little tricky on this one. So with this one, that would be, let's see, that would be over here at pi over 6. All students take calculus, so it would be over here at 5 pi over 6. Right, so again, got to get back to knowing our unit circle, but that's where we have those values. So what that means is that 3x equals pi over 6, or 3x equals 5 pi over 6, which seems fine, right? Very, very doable there. The problem is, though, is we're going to take, to get x by itself, we're going to divide by 3, correct? So it's going to become pi over 18. Okay. And this would become 5 pi over 18. Right? So those are two solutions. Right? Here's the problem, though, is that these are just two solutions, but it doesn't list all the solutions from 0 to 2 pi. There's actually more solutions in there. And what's going to happen is, because we're multiplying, or like we're dividing by 3 here, you actually have to go look all the way out 3 times as far as you normally would. So instead of going out to 2 pi, we have to go all the way out to 6 pi to get this to work. Right, because we're dividing everything by 3, we're pushing everything back into those first rotations. So a couple ways we could manage that. One way, the way I would probably recommend you do it, is just write this like we're solving for all values. Right? If we're solving for all, you'd say plus 2 pi k, right? And then here you'd say 3x equals 5 pi over 6 plus 2 pi k. Right, so that's all solutions, correct? So it's pi over 6, plus it's a full rotation plus pi over 6, or 2 full rotations plus pi over 6. We're listing all the solutions. Now once you've done that, so it didn't matter here because of the 1/3. Pushes things out. This needs to push things in. So here we're still going to multiply by 1/3. So we get pi over 18 plus 2/3, or 2 pi over 3k. Just kind of scary looking, right? And then we get x equals 5 pi over 18 plus 2 pi over 3k, which is strange. Now I know that I need to write these out, I need to find them. So I'm going to just get a common denominator because I know I'm going to be adding them anyways. So let's write this as x equals pi over 18 plus 12 pi over 18 k, and then 5 pi over 18 plus 12 pi over 18 k. And you might be thinking, why in the world are we bothering to make it over 18? But as we look, if you do k as 1, or I'm sorry, let's start with k as 0, right? So our actual solutions will occur when k is 0, 1, and 2. We could test 3, but it's going to be outside of the interval. So with that, if I put 0 in here, I get x equals just pi over 18. But if we put 1 in here for k, right, you get 1/18, or pi over 18 plus 12 pi over 18, which is 13 pi over 18. If you put 2 in here for k, you get 24 pi over 18, which gives you 25 pi over 18, right, which is still smaller than 2 pi. Right? But if you put 3 in here, you get 36 pi over 18. That gives you 37 pi over 18, which is too big. It's out of the interval. Okay? So then for this one, we'll start with 5 pi over 18. We'll add 12 pi over 18 to get 17 pi over 18. And then we'll add 2, k is 2, so that'd be 29 pi over 18. So those would be the 6 solutions in this interval. That's about as hard as it ever gets for that type of problem. They're a pain. You just got to kind of remember the technique. But here's for our last one. We have 2 cosine squared x minus 1 equals 0. Again, we're just solving from 0 to 2 pi. Again, it's just an x in here, which is going to make it a lot easier than that big mess was over here. So that's a good thing. But there is a chance, I guess, you could factor this. But if you just have a single, if the only cosine is being squared, then your best bet is just to solve for cosine. Just isolate it. So in this case, 2 cosine squared x equals 1. Divide by 2. Cosine squared x equals 1/2. Now to get rid of a squared, like we always do, we're going to square root both sides. But remember, that means one side gets a plus or minus. That's where people tend to miss this, is they forget the plus or minus. Anytime you're solving an equation and you decide to take an even root of both sides, you have to include a plus or minus sign. So we'll get the cosine of x is plus or minus the square root of 1/2, which looks really strange. It's like, we're not used to that number. But actually, if you rationalize it, that's just radical 2 over 2. So it's saying the cosine of x is equal to positive or negative radical 2 over 2. So if we think about a cosine function, I know up here at pi over 4, it's equal to radical 2 over 2, correct? All students take calculus. And then down here at 7 pi over 4, the cosine is radical 2 over 2. And then for negative, we're over here at 3 pi over 4 and 5 pi over 4. Right, so we get 2 answers for the negative, 2 answers for the positive. So then we get x equals pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4 would be our 4 solutions there. Before we leave this one, I'm guessing maybe that this step might have goofed some people up. I don't know, but that's just rationalizing a, let's look at it. So I had plus or minus the square root of 1/2. Now we know that you can always write that as just radical 1 over radical 2, right? You can square root the top and the bottom, which gives you 1 over radical 2. Then we have to rationalize it, which gives us plus or minus 2, or radical 2 over 2. So that's how we did that. That's a fact that shows up all the time. Probably just want to get used to seeing that. But you can see this again. The big thing, the reason people miss this is that they forget the plus or minus sign. Like any time things are being squared, that tends to be the problem.